Good morning students. Today I am going to explain you chapter 1 rational numbers of class 8. Aim of the chapter is to know about rational numbers and its properties. We frequently come across simple equations to be solved. For example, x plus 2 equals to 13 is solved when x equals to 11. Put x equals to 11 in the left hand side, then it becomes 11 plus 2 equals to 13 and right hand side is also 13. So x equals to 11 will be the solution of this equation where 11 is a natural number. See second example, x plus 5 equals to 5. The solution of this equation will be 0 where 0 is a whole number. 2x equals to 3. Transpose 2 to right hand side, then the value of x will be 3 upon 2. And then the next example, 5x plus 7 equals to 0 is solved when x equals to minus 7 upon 5. That is, firstly we will transpose 7 to right hand side, then I can write it as 5x equals to minus 7, then the value of x will be minus 7 upon 5. We already know about natural numbers and whole numbers. Now the numbers 3 upon 5 and minus 7 upon 5. What about these numbers? These type of numbers, we need these numbers 3 upon 2 and minus 7 upon 5 to solve the equation third and fourth. This leads us to the collection of rational numbers. Definition of rational number. A number of the form p upon q where p and q are integers and q is not equals to 0. That is, the numerators and the denominators are integers and the denominator is not equals to 0. The set of rational numbers is denoted by q. For example, 3 upon 4, 1 upon 5. The numbers 3 upon 4 and 1 upon 5 are rational numbers since both the numbers can be written in the form of p upon q, and 3 and 4 and 1 and 5. All these are integers and the denominator, that is 4 and 5, is not equals to 0. Similarly, 2.3, it can be written as 23 upon 10. 0 is also a rational number since 0 can be written as 0 upon 1. Next, all natural numbers, whole numbers and integers and fractions are rational numbers, and the rational number 0 is neither positive nor negative. Observe this figure. First, natural numbers 349, 12, 5, whole numbers 0, 1, 2, integers minus 3, minus 10, minus 24, and the rational numbers, that is the set of all natural numbers, whole numbers, integers, all are rational numbers. Next, properties of rational numbers. First property is closure with respect to addition. Let us add any two rational numbers. Take the rational numbers be 3 by 8 and 2 by 8. Take their sum. Since the denominator is same, need not to take the LCM. Just do the addition of the numerators. 3 plus 2. 3 plus 2 will be 5. 5 upon 8. Thus we observe that the sum of two rational numbers is always a rational number, that is 3 by 8, 2 by 8 and 5 by 8. All these are the rational numbers, hence therefore rational numbers are closed under addition. Next property is closure with respect to subtraction. Let us subtract any two rational numbers. Rational numbers are 3 by 8 and 2 by 8. Do the subtraction of both the rational numbers, that is 3 by 8 minus 2 by 8. Answer will be 1 by 8. Thus we observe that the difference of two rational numbers is always a rational number. Hence rational numbers are closed under subtraction. Next is closure property with respect to multiplication. The product of two rational numbers is always a rational number, that is If A upon B and C upon D are two rational numbers, then A upon B multiply C upon D is also a rational number. For example, 3 by 8 and 2 by 8. Do their product, 3 2s are 6 and 8 8s are 64. Convert it into its simplest form, answer will be 3 upon 32. Answer is a rational number. 3 by 32 is a rational number. That is, when we will do the product of any two rational numbers, answer is again a rational number. Hence, rational numbers are closed under multiplication. Next property is closure with respect to division. That is, if A upon B and C upon D are any two rational numbers such that C upon D is not equals to 0, then A upon B divided by C upon D is also a rational number. That is, the set of all non-zero rational numbers is closed under division. Next result is, for any rational number A upon B divided by 0 is not defined. Next is, as 0 is also a rational number, we conclude that rational numbers are not closed under division. Thus, we conclude that rational numbers are closed under addition, subtraction and multiplication, but not closed under division. Next property is commutative with respect to addition. Let us add any two rational numbers in different order. Take two rational numbers 3 by 8 and 2 by 8. Take their sum, 3 by 8 plus 2 by 8, answer will be 5 by 8. Now interchange their places. In this case, we will add 2 by 8 plus 3 by 8. Answer is again 5 by 8. Thus we find that rational numbers can be added in any order. Hence addition is commutative for rational numbers. Next is commutative with respect to subtraction. If A upon B and C upon D are any two rational numbers, then A upon B minus C upon D is not equals to C upon D minus A upon B. Let's take one example. 2 by 3 minus 3 by 4. Denominator is different. Take the LCM of the denominator. LCM will be 12. 3 4s are 12, 4 4 2s are 8. 12 divided by 4 will be 3, 3 3s are 9. As we know that plus minus will be minus, 8 minus 9 will be 1. 9 is bigger number, it's negative, then answer will be minus 1 upon 12. Similarly, now do the subtraction of 3 by 4 minus 2 by 3. You will get the answer 1 upon 12. As minus 1 upon 12 and 1 upon 12 are not same, hence therefore subtraction is not commutative for rational number. Next property is commutative with respect to multiplication. If A upon B and C upon D are any two rational numbers, then A upon B multiply C upon D equals to C upon D multiply A upon B. That is, we can do their product in any order. For example, 2 by 3 multiply 3 by 4. Do the product of the numerators. 2 multiply 3 will be 6 and product of the denominators 3 multiply 4 will be 12. Convert it into its simplest form, answer will be 1 by 2. Now interchange their places. 3 by 4 multiply 2 by 3. Again answer will be 6 upon 12, that is 1 upon 2. Since 1 upon 2 and 1 upon 2 both are same, hence multiplication is commutative for rational numbers. Next property is commutative with respect to division. That is, if A upon B and C upon D are any two rational numbers, then A upon B divided by C upon D is not equals to C upon D divided by A upon B. Let's verify it with one example. Let A upon B equals to 2 by 3 and C upon D equals to 3 by 4. 2 by 3 divided by 3 by 4. Change divide into multiply and do the reciprocal of the next term. It can be written as 2 by 3 multiply 4 by 3, that is 8 upon 9. Now interchange their places. 3 by 4 divided by 2 by 3. Again change divide into multiply and do the reciprocal of 2 by 3. It will be 3 by 2. Then answer will be 9 upon 8. Since 8 upon 9 and 9 upon 8 both are not same, hence division is not commutative for rational numbers. Thus we conclude that addition and multiplication is commutative for rational numbers, but subtraction and division is not commutative for rational numbers. Next property is associative. Let us add any three rational numbers in different order. For example, start the bracket 3 by 4 plus 1 by 4, close the bracket, plus 7 by 4. Firstly, we will take the sum of 3 by 4 plus 1 by 4, and after that we will add 7 by 4 to it. 3 plus 1 will be 4, 4 by 4 plus 7 by 4, answer will be 11 by 4. And that is on the other hand, now 3 by 4 remains as it is. Firstly, I will do the sum of 1 by 4 and 7 by 4. 1 plus 7 will be 8. Now add 3 by 4 to it, that is 3 by 4 plus 8 by 4. Answer will be 11 by 4. We find that three rational numbers can be grouped in any order to find their sum. That is, addition is associative for rational numbers. Next, associative property with respect to multiplication. If A upon B, C upon D and E upon F are any three rational numbers, then start the bracket A upon B, multiply C upon D, close the bracket, multiply E upon F. That one is equals to, now firstly do the product of C by D, multiply E upon F, and do its multiply by A upon B. Firstly, we will solve the left hand side. Let A upon B equals to 3 upon 4, C upon D equals to 1 by 4 and E upon F equals to 7 upon 4. 3 1 ja 3, 4 4 ja 16, multiply 7 upon 4. 3 7 ja 21 and 16 4 ja 64. Now solve right hand side, put all the values there and firstly solve the bracket. That is 3 by 4 remains as it is, 1 7 ja 7 and 4 4 ja 16. Again the answer is 21 upon 64. Since both the sides are same, hence therefore the multiplication is associative for rational numbers. Now the associative property with respect to subtraction. If A upon B, C upon D and E upon F are any three rational numbers, then start the bracket A upon B minus C upon D, close the bracket, minus E upon F. That one is not equals to, firstly do the subtraction of C upon D and E upon F, and after that we have to subtract only A upon B. Both the sides will not same, hence therefore subtraction is not associative for rational numbers. Similarly for division. Division is also not associative for rational numbers. You can prove it by taking examples. Thus we conclude that addition and multiplication is associative for rational numbers, but subtraction and division is not associative for rational numbers. Next property is existence of additive identity. Observe these examples. 2 by 3 plus 0. We know that if we will add 0 to any number, we will get the same answer, that is answer will be 2 by 3. And on the other side, if we will add 0 plus 2 by 3, that is if we will take the sum of 0 and any other rational number, then again we will get the answer, that is same rational number we will get. Hence therefore 2 by 3 plus 0 or 0 plus 2 by 3 equals to 2 by 3. Thus we observe that the sum of any rational number and 0 is the rational number itself. Thus 0 is called the additive identity for rational numbers. Next is existence of additive inverse. Which rational number should be added to 8 upon 9 to get the sum 0? We know that if we will add any number to its negative, then always we will get the answer 0. Now the rational number is 8 upon 9 and its negative will be minus 8 upon 9. That is 8 upon 9 plus minus 8 upon 9 or minus 8 upon 9 plus 8 upon 9. Answer will be 0. Hence 8 upon 9 and minus 8 upon 9 are the additive inverse of each other. Thus we conclude that for every rational number a upon b, there exists a rational number minus a upon b such that a upon b plus minus a upon b equals to 0. Next is existence of multiplicative identity. If a upon b is any rational number, then a upon b multiply 1 equals to 1 multiply a upon b equals to a upon b. Hence the product of any rational number and 1 is the rational number itself. Hence therefore 1 is the multiplicative identity for rational number. Now the next property is existence of multiplicative inverse. For every non-zero rational number a upon b, there exists a rational number b upon a such that a upon b multiplied b upon a, that one is equals to b upon a multiply a upon b equals to 1. That is, if we will do the multiplication of any rational number by its reciprocal, then always we will get the answer 1. Hence, b upon a is the multiplicative inverse or reciprocal of a upon b and vice versa. Next result is there is no rational number which when multiplied by 0 gives 1. Thus 0 has no reciprocal. Next property is distributive of multiplication over addition and subtraction. Firstly, we will discuss about distributive of multiplication over addition. If a upon b, c upon d and e upon f are any three rational numbers, then a upon b multiply bracket start c upon d plus e upon f bracket close. Open the bracket. Firstly, do the multiply of a by b. A upon b multiply c upon d plus a upon b multiply e upon f. Now, distributive of multiplication over subtraction. If a upon b, c upon d and e upon f are any three rational numbers, then a upon b multiply bracket start c upon d minus e upon f bracket start bracket close. Do the product of the numbers. A upon b multiplies c upon d. After that the negative symbol is given to us, so then we will put the minus sign. A by b multiply e by f. Thank you.